how to operate your machine that you are intending to use for your laser cutting job. Okay, so first of all, some basics on the optics. How does a laser cutter actually work, or how does a laser work? Well, we're not going to look at how the laser works, but what it does is it produces light, shown by the red arrows on the screen. So basically these come out fairly collimated. Like if it's a good laser, it should be fairly collimated. Collimated means these lines come out in parallel, so the light doesn't actually spread out. It doesn't diverge much. And this light is basically positioned inside of the laser cutter on a horizontal plane. So the first thing that we need to do is deflect it downwards onto the material that we are actually going to work on. So that's this 45-degree angle mirror up here. And then what we also want to do is send it through a lens that will basically bundle up the individual beams of light together to kind of focus it onto the so-called focal point, because we're basically bundling the energy together. So this is where the energy will be the strongest, because we have a lot of light, a lot of energy being put into a single point on to the surface of the material that we are working on. So that's what we want to do. Now let's just say, for the sake of argument, that somebody had been using the laser cutter before you and they were working with 4mm thick material. Now you come along with your material and this is only 3mm wide, and what you can immediately see is that the focal point is completely off, meaning that the light that is hitting the surface is spreading out over a wider area onto the actual surface, meaning that the energy per individual spot that you might look at on your surface of the material will see less energy being induced into it, or less thermal energy in this case. So this isn't great, because we would like to have a maximum power or energy being introduced in the material. So what we can do is, I guess the most intuitive thing would be to move the lens, but that's not actually what we're going to do, because it turns out this mirror and this lens is one optical component inside the laser cutter. In fact, this is the optical component that actually moves about on the horizontal axis and in and out of this page. So what we do instead is we move the bed, the grid that the material rests on, we move this up, because this can actually be controlled. So what we want to do is basically move it up. So I left this line just for reference. This is the top of the grid that the material rests on. So if we shift this up just enough so that the surface actually coincides with the focal point, then we're exactly at the sweet spot where we want this material to be. Now, this is what it looks like in real life. I'm sorry the image is a little bit dark. I hope you can still see the details. So here we have a neon yellow piece of material, acrylic material, or some leftovers in fact, resting on a metallic grid, which is the bed of the laser cutter. And this is the part that can be moved up and down. Now, this black metal bar at the top that you can see, this is basically the rail where the optical component, so this part, the mirror and the lens, will be moving left and right on this rail. Now this rail itself can actually move forwards and backwards. So with forwards and backwards and left and right motion, we basically cover this whole 2D area of the laser cutting workspace. Now, as you can see here, this tiny little metallic thing, if we zoom in, this is what it looks like. You can flip this down. All it is kind of a measurement tool that kind of helps you measure the correct distance. And what you want to do is you want to move this material up just enough such that the tip of this little measurement tool just barely touches the surface of your material. This basically means that now your piece of material that you're working with, in this case acrylic, is in the exact sweet spot in the focal point where you would like the material to be in order to get a very clean result. So what can we actually do with a laser cutter? There are basically two tasks that are relevant. One is engraving and the other one is cutting. So you want to be able to cut an outline, or maybe even on the inside. If you're using, I don't know, something like a keychain, you might want to have a little hole inside of it as well. But usually it's a matter of cutting around the outer edge of an object. And what you want to do is introduce enough heat for the material to actually melt or burn away, to actually create a tiny little bit of a gap. Now, obviously, none of these images are to scale, so these are highly exaggerated. This is not what it looks like in real life. But yes, it is a subtractive process, abtragendes Verfahren in German, meaning that you are taking away a little bit of material here. Now, in real life, this laser beam is obviously, I don't know, super small. It's like as wide as, I don't know, a hair or something, you know. So this gap is not this wide. It is barely visible with the eye. Sometimes these edges are actually so close together that you need a little bit of pressure with your fingers to actually push the inner object out of its surroundings, especially depending on the settings of the laser. If you didn't fully cut through and maybe there's just a tiny little piece of material left at the very back. Now, this really heavily depends on the settings of your laser cutter. This is nothing you should really be worrying about as a beginner. So let me just say that if you have trouble with that, always check in with whoever owns or is in charge of the laser cutter and can help you out with tweaking the settings a little bit. The settings that you can play around with is the power of the laser. So this can be attenuated. You don't have to work with 100% power. And the speed at which the laser, the optical, so these components move about, that speed can also be adjusted. Of course, the faster you move, the less energy will be introduced into the material per section, right? And the slower you move, the more thermal energy will be introduced. And you want to introduce just enough energy in order to be able to cut through, but you don't really want to introduce more energy than necessary, because this will damage the surroundings and can even lead to the edges melting away and looking rugged or something. Like you don't want to do that. So that's very specific, but usually you don't need to worry about that because you get presets from the software that controls or talks to the laser cutter, where you basically upload your files into. These should be stored in the presets that you're using, so you shouldn't really be worrying about that. Now, the other mode of operation or task that a laser cutter can do is engraving. Now, what you want to do with engraving is just damage the surface just a tiny little bit. So yes, you're basically burning away a tiny little bit of material here, but if you only touch the surface just a bit, it's enough to be visually, visible, but it's not going to, so this again is extremely exaggerated. Of course, it doesn't go in this deep, but again, this also depends on the specific settings. Now, here is an example of a acrylic keychain. This is a very small piece, only a few centimeters. So this is heavily zoomed in, and what you can see here is the cutting the outer edge, and this is actually a good one here. So the settings weren't perfect in this case, which kind of makes this great for demonstration purposes. So two things you can see. First of all, if you look at these little things sticking out here, I hope you can see it well enough on your screen. That's a little bit of leftover material, basically meaning that the laser hasn't fully cut through the material. So there at the bottom here, there was just a tiny little bit of connection, which was thin enough to be able to break out or break through. But this can also cause edges to chip off. So in this case, we were lucky because it was extra material that was left over on the piece that we were actually, that was the good part, not the extra pieces around it. So this would be easy to just simply clean it up with a little bit of a cutter knife, and then you'd be good to go and hand this out to someone as a present or whatever. So yeah, this is okay. But the other thing that you can see, which is also fine because you're always going to be able to see it just a little bit, is these lines. these tiny little lines. And what that is the individual laser positions. So as this laser beam moves across this line to cut it through, what is basically happening, if we go back to this image here, this bar, this rail, is slowly moving backwards, while the optical component mounted on this rail is slowly moving to the right. So basically the bar is moving this way, the optical components are moving that way, and the little like steps you can see here, that is the step size of the motors actually. So this isn't the laser, this is the motors, that's the step size of the motors. So this is why you can see little individual lines here. Now if we take a closer look at the engraved area at the top, you can also tell, first of all, I can tell that this is not the position this piece has been processed in. In fact, this has been flipped around by 90 degrees, so it's been lying this way instead of this way. And the reason I can tell is because the laser engraves on the horizontal axis. So basically, the optical component on this rail is moving back and forth, left and right. And those are the lines that you can see up and down on this image here. So because how do you actually create an area with a single spot of light? Of course, you have to draw a line and then move over just a bit and draw another line and then move over just a bit and draw another line. Of course, this would be on the horizontal axis. And this is how you create an area. So you can think of it a little bit like an old school TV. You know, those vacuum chamber, electron beam, really heavy, clunky things with a screen at the front where the electron beam would be converted into visible light. Basically, it's a tiny little spot of light making its way across the screen in lines. And because our human eyes are slow enough, we don't actually have the enough time resolution to be able to see that it's actually just one spot of light kind of moving across the screen, so it actually looks like a complete picture. And this is kind of similar like that, except that we are damaging the surface of the material. And this way, you can actually see the individual lines here from the movement of the laser cutter. Do wrong with the material itself. There's a lot of stuff that can go wrong with the laser cutting and the processes or the settings, but the material itself is not very problematic. It's pretty easy to handle. Wood can be a little bit more difficult to handle, so if you have proper expensive wood that is basically being marketed as wood that can be used in a laser cutter, it will be expensive wood, but you will probably not have any issues with it. So there's mostly two things to look out for with wood is, first of all, it needs to be perfectly plain, so the surface needs to be perfectly even and not be slightly curved and bent, which, knowing wood, especially if it draws a little bit of moisture, something like this can easily happen. So make sure that the wood that you're working with is perfectly level, because if it isn't, if we go back to one of these images, basically if you imagine this material kind of curving up in the middle, what you get is basically this situation where you're spreading out the energy over a larger surface area, which is not what you want. You're not going to get a clean result. You might get a very rugged result for the engraving job, or you might not be able to cut through the whole material if it's a cutting job in that particular position. So yeah, that is definitely something to look out for. All of the materials that you're using have to be perfectly flat and even. The other thing to look out for with wood is that not every wood is laser cuttable, or to be more precise, not the wood itself, but the glue that has been used to keep the wooden layers together. So usually, for the most part, you will most likely be using plywood. Plywood means it's been glued together. Not all types of glues that are being used are actually laser cuttable. So if you walk into a hardware store and don't pay attention to, if you go into a crafting store, buy expensive material that is meant for laser cutting, you're not going to have any issues. But if you walk into a hardware store instead and buy cheaper woods, it can easily happen that the wood is not actually processable by the laser cutter. And in fact, it's not the wood, it's the glue inside. Another thing to look out for is that the wood needs to be perfectly dry and clean. So no oils, no resin stains, and neither natural resins nor epoxy resin or any other kind of stuff on it. Like, all of the material must be absolutely clean. Okay, so these types of materials are the most common and the easiest to use. And then there's a bunch of other things, and this is again not a complete list. There's paper, there's cardboard. You can use fabric. It's highly recommended to use 100% cotton, because as soon as there is any other kind of material in there, you'd have to do research on that particular material, whether or not it is actually, can be used in a laser cutter. Because especially synthetics can easily catch fire or melt away and basically not be processable by a laser cutter. You can stack several layers of cotton. I've done it before. We did that for our mask project in the beginning of the pandemic. We created a lot of hand-sewn or machine-sewn, handcrafted masks, and we got tired of cutting out the fabric ourselves by hand, so we decided to use a laser cutter instead. So it can be done, but it's very easy to catch fire. So again, not the easiest thing to start out working with. You can also do leather, as long as you make sure that it hasn't been processed with any chemicals or oils or anything like that. If it's clean leather, you can use that as well. Cork I've used before. That is also fun to do. Basically works the same like wood, more or less. Rubber for stamps, the only thing I can say here is, yeah, it's a lot of fun to make your own custom-made stamps, but it has to be rubber that is actually processable by a laser cutter, because the regular stamp rubber that you can buy in crafting stores will be made of PVC, also known as vinyl, which you may not use in a laser cutter. Don't do it. And then there's a few more fancier materials like glass. Depending on your specific laser cutter, you might be able to do some engraving on glass. Metals are even a little bit more tricky, so you have to do some research on what your laser cutter can actually do. Also, not every laser cutter can do every depth of the material or the thickness of the material. So, maybe 5 or 6 millimeters is already a lot. So if you have 7 millimeters to process, maybe your laser cutter won't be able to actually process the material, but it highly depends on the material itself. So, and the other thing to look out for is the maximum size of material that you can even fit into the laser cutter. So if you have a 40 by 40 centimeter square piece of acrylic, but the laser cutter can only handle up to 30 centimeters in one dimension, you are not going to be able to fit that piece into the laser cutter. So it won't work. So make sure that your raw material that you're using, it will actually be compatible with the specific machine that you are going to work with. Here are some examples of what acrylic can look like. So they come in all kinds of different colors. They come in opaque colors like the blue, the green, the yellow, the black to the left, but they also come in slightly transparent, like for instance this black grayish looking semi-translucent kind of acrylic. So, and the one to the right, these are actually two different pieces. One is white acrylic, the other one is transparent acrylic, but there's a white protective layer sheet stuck onto it. That's why it looks white. This is actually transparent. The top left is neon colored, so unfortunately this doesn't really show up well on camera, but this is the neon yellow that you've seen before in these images. It shows a little bit more neonish here on these images, but yeah, it's really difficult to capture by camera, and this is a neon orange type of color. Now, the one in the middle, this is actually a lot more interesting because this is a mirrored acrylics, which means that it's clear, transparent acrylic with a layer of like metallic coating on the back. So basically like a regular mirror made of glass, where you have a coating on the back. If you've ever seen a damaged mirror or scratched the surface, you will notice that the property of mirroring and deflecting the light actually disappears and it turns into just regular plain old glass. And this can actually be used pretty neatly with laser cutting. And this is what it's going to look like. So the part on the left, these are keychains I made for a friend a couple of years ago. And this piece on the left, you can tell that this is the mirrored area. And the milky white area, this is the area that has been engraved by the laser cutters. So basically what you do is you process it from the back and you remove the mirror coating. Here's another fun project. This was a stamp I made from laser cuttable stamp material. This is also kind of expensive, but it was a lot of fun to fiddle around with. And yeah, speaking of which, there's a couple of things that I'd like to mention just because I've seen people do it in hackspaces, and you really shouldn't be doing this kind of thing. So first of all, even if you think you know your way around a laser cutter, don't walk away during a laser cutting job. I know it can take a long time. Sometimes if you have a bigger project or if you have a lot of area that you need to engrave, it can take 20, 30 minutes for a single job to get done. This doesn't mean that you can simply walk out and grab some lunch, because by the time you get back, the fire brigade might be greeting you at the entrance door because you created a fire. So yeah, this has happened before. If the motors, for instance, fail inside the laser cutter machine, the laser will think it is moving while it is not, and it will be introducing a lot of heat on the same spot of the material. It will eventually catch fire, then the machine will catch fire, and essentially the room will be on fire. You really don't want this kind of thing to happen. So even if you think you're safe, you might not be. So just keep that in mind. Never walk away for more than 2 or 3 minutes from a laser cutting job. Always make sure you check back regularly. Also, do not just use any material in the machine by simply trying out if it works. Like this is, like I said before, if you use wood from a hardware store, you don't really know what kind of material is inside of the plywood, what kind of glue they've been using. So it's generally not a good idea to do that. Some people do it in hack spaces. I wouldn't really recommend it, but if you want to save some money, it is doable. But either way, just make sure that any of the materials that you're using is definitely not PVC or vinyl. Like for instance, a typical stamp rubber that you can buy in crafting stores, like the cheap ones you can basically handcraft. Those are not safe for laser cutting. Why? Because they release some gases that can actually corrode the laser, usually chlorine gas, and some of the materials can easily catch fire that are not meant to be used inside of a laser cutter, so just be aware of that. So on top of not using PVC, leather might have been treated with unknown chemicals, be aware of that. Fabric that isn't 100% cotton is probably not a good idea to be using, or materials that are covered with epoxy resin, like for instance I had some leftover acrylic pieces from an older job. I took the box apart and wanted to reuse the pieces. I made sure not to hit the epoxy resin because that was the glue that I used to glue the pieces together, and there were some stains on it. I made sure not to laser over it, but something went wrong with the reference point or something, so I did laser over a little bit of epoxy resin. I immediately stopped the job, of course, but you could immediately smell that just from the fumes coming from that stuff. Like, this is not healthy and you really shouldn't be doing this. And like I said before, make sure that wood doesn't contain any oils or natural resins, because this can also easily catch fire. Again, this is an incomplete list. There's a lot more things that you shouldn't be doing with a laser cutter, but this is not what this talk is about. So yeah, get your introduction from your local hackspace and make sure they teach you everything that you need to know. And if in doubt, read the manual. It's really no excuse saying that, oh, I didn't know this. Just read it up, do your research. It's not a big deal. Okay, so now to the fun part. Preparing files for laser cutting. So how do I actually create files that can be read by the machine, or to be more precise, the computer that talks to the laser cutter and sends the file over? So usually what you will have is a computer running a software, like for instance VisiCut. In this talk I'm only ever going to mention free and open source software, so VisiCut is one of them. File extensions that this particular program can read is the vector graphics SVG file. It can also understand EPS, DXF, and a specific VisiCut file. So how do you create these files? Well, there's multiple ways how to get there. One way is if you already know, if you're an engineering type of person, or you've used CAD software before, like for instance FreeCAD or some other tool, you can easily do that to design your pieces and then simply export the drawings to an DXF format. And this will actually be readable by a laser cutter or by the software processing the files for the laser cutter. So this is not an issue. If you already know your way around CAD software, this is one way to go. Now, of course, using 3D software, or CAD software that is intended for 3D design, is not necessarily the best tool for the job if we're talking about a 2D process, because laser cutting really is a 2D job. But if you have a very extensive, complicated project, like, I don't know, some kind of 3D puzzle, or I remember as a kid I used to have these wooden pieces, like laser cut pieces, that kind of were able, like a 3D puzzle, you could put it together and it would end up being a skeleton of a dinosaur or something like that. It was just some toy thing. But if you want to create something that can be put together to create a 3D object, it might make sense to use a CAD software. But personally, I've never really done that. I mean, I did it once. I exported a file to DXF just to try it out and see if it works, and it works perfectly fine. There's not much you need to worry about. So if you already know how to use CAD software, then go for it. But if you are new to it, this is kind of maybe a little bit overpowered for the job, so you don't really need to do that. A much easier way to get started is actually some online helper tools, like for instance makercase.com, and I'm going to switch over to the website. So if you open up makercase.com, you will get a selection of different types of boxes that you can generate using the software. I usually go with the most simple basic box to the left, so I'm just going to click on that. And here you can see a preview of the box that we are generating here. Now, the first thing you should do is switch to some proper units, which is millimeters, because we're in Germany here, so we want to be working in millimeters and not in inches. And then we can define the size of the box. We can also define, are these the outside or the inside measurements. And another thing you need to look out for is the material thickness. So 3 millimeter is good. Most material that I work with, most acrylics and most wood materials are either 3 or 4 millimeters. 6, 9, and 12 is way too much, but you can also enter a custom thickness and go with, I don't know, 4 millimeters or something like that. We're going to stick with 3 for now, and let's define the height to be maybe 3 centimeters. Well, let's make it 5 centimeters. So let's say I want to create a little box for my electronics project, and maybe it's a long-ish PVC. So let's make this 10 centimeters wide and maybe also 5 centimeters. Yeah, tiny little box, why not? Okay, so is the box open or closed? Of course, we can make it an open box, like for instance, I don't know, maybe I want to have a decorative box in my bathroom to collect my hairpins and needles and ribbons and stuff, and personalize it a little bit and maybe write my name on it or put a logo or something pretty on it. I could do that, but for the most part, if I'm designing something to put my electronics into it, I probably want this box to be closed and have a lid. Scrolling down, we can also see the option here called edge joints. We want to set this to fingers. And these are pretty big fingers, so I actually want these to be a little bit smaller. So let's just, maybe like this, looks good. The reason being, I'm zooming in with my mouse wheel, and I'm dragging around just with my mouse to change the view here. So what we want to do is we want to have these little fingers sticking out, because this makes it a lot easier to glue the pieces together. In some cases you might not even need glue, like especially for wood, sometimes the pieces just simply stick together. They also fall apart very easily, so it always makes sense to use some glue to keep it together. If you're using acrylic, you need to keep in mind that you need to use special glue that is actually capable of gluing flat acrylic surfaces together. So that might be special epoxy resin that and there's different types of epoxy resin, so you need to make sure that the type you're using can actually be used for plastics as well. But in case of wood, you can simply use like quick dry glue or a hot glue gun, something like that. Now, if you don't have that, if you have the flat surfaces, like this is not a very stable construction, so you always want to use the fingers instead. And when you're done and happy, and maybe you want to define the outer or inner dimensions depending on do you want to optimize it for the electronics inside, or do you want to optimize the outer dimensions? So yeah, some decisions that you can make. When you're done, you can click on Download Box Plans, and again, you have at the bottom, I actually never fiddle around with these settings here. I never took a closer look at it. Basically, all I care about is download SVG. You can also use the DXF format, but since we'll be using Inkscape for the vector graphics, we are going to download the SVG and then work with that, which I have actually already done. So this is what it looks like when you open it up. Now, I don't know if you can see it because I'm going to ungroup the objects and I'm going to increase the stroke style just so that I hope you can see it a little bit better on screen. The stroke size actually doesn't really matter, as we will learn in a bit, but just so you can better see what we are working with here, this is what this file looks like. So this is a vector graphics file that has been generated by this website. And I open it up with a program called Inkscape. You can download it at inkscape.org, I believe, /download. So yeah, so what you see here is the individual parts of this box with the fingers and the cutouts. And there's also some labels to tell you what is what. So that's kind of useful, and this is a nice box. But now, first of all, I might want to have a label, I don't know, at the top. So I might want to add something like, this is my project. And maybe I want to use a nicer font. Something like this, maybe. And now I have customized my box a little bit. Also, if I'm handling electronics, I probably have some wires going in and out, unless I'm using a battery inside of it. So I probably will want, if this is, well, these labels aren't right. So if this is the back, maybe I have a hole and I can hold Control actually to make it symmetrical. And I don't actually want a filling, but I do want an outline. And let's make this full opacity and also red, in fact. So let's copy this color over to this object to make it red. And the stroke thickness, the width, doesn't actually matter. But so here I could define, okay, I might want to have basically drill a hole into it that is, again, we are working in millimeters here because that's the units we selected when we generated the file. And here with the height and the width, I can define, okay, maybe I want an 8 by 8 millimeter diameter hole drilled into it to get some cables in and out of the box. So maybe I want to position it a little bit nicer, maybe I want it in the center, depending on what my electronics look like, but this is a really neat and easy way to do things. Now I could save this and upload it or copy it over to the machine that talks to the laser cutter and almost be done with it, but really not quite, actually. Because one thing we need to look out for is that this is a text object and this is a circle object. This is not yet a so-called path. So here's the bit where you need to start learning about what vector graphics are and how it works. I cannot give you a complete introduction and tutorial on Inkscape and vector graphics in this talk, but just be aware that there are different types of objects, but what you want to be working with is basically paths. So right now this is a circle object, so we need to select object to path, and we need to do the same with this text, because right now it's a text object, so we need to create object to path. And now if we take a look at the nodes, we can actually tell this is not text anymore. I can actually edit the graphics of the text, but I cannot edit the text itself. Like I cannot add or remove. I mean, I can always delete parts of it, but it's not like I can click with the text tool and then this just creates another layer of text on top of it. I cannot edit it anymore. So now I cannot edit my text anymore, but now it will be under some. As you can see, is 2.9 millimeters. So it's basically, that's because I didn't position this correctly, but this is basically 3 millimeters wide. So you need to have in mind, I hope you can see, it's a very tiny number here, but so you need to have in mind that depending on what material you use, these box settings will actually change. So you cannot do 2 millimeters or 4 millimeters with this kind of layout because it won't match, it won't fit. The fingers of this part won't fit perfectly into these openings. And if it's thicker, it won't fit at all. So you need to keep that in mind. So before you even start designing your files, you need to know what kind of material are you working with. In this case, I actually used 2 millimeter clear clear acrylic for the LED cube, and then this black acrylic is back to 3 millimeter LED. So the black and shiny acrylic is meant to hide the electronic box. And just for reference, this was the test setup to test the electronics, but this is what it looks like when it's powered on. Also, what you can see here to the right is an example of these are wooden drink holders that you can simply screw onto the wall. This has also been created with the makercase.com tool, and then I basically edited and customized the files a little bit in Inkscape because it's a pretty simple job, so it wasn't too much hassle. But yeah, the more complicated your jobs will be, the more likely it might be that it might be more useful to actually use a 3D CAD design program instead of vector graphics. But this was still simple enough to be able to do. And another thing I want to point out with the black bottom part here, with the LED cube, which is positioned upside down here, obviously, but this is the bottom of the cube, and what you can see is 1 millimeter thick wires sticking out, and this pattern of holes, I basically drilled, quote unquote, these holes into the acrylic by laser cutting them into it. So all I did was create a square and then a bunch of circles inside, and obviously made sure that they had the correct size and the correct positions and stuff like that. And that's how I created this plate here. And the nice thing about it is you can work, this is very high precision. So the holes are just slightly bigger. I don't know if the wires were 0.9 millimeter. The material gets heated up, and as it cools down, it will actually contract just a tiny little bit, which can actually create little differences, and a little bit of tolerance should always be considered, whereas with a laser cutter you can get extremely precise results. All right, so you need to know about the machine. We already covered that. You need to be able to know what type of materials can your laser cutter handle. Not all laser cutters can do the same materials. Metals, for instance, can be done by very big, expensive, and professional machines, but not necessarily by the type of laser cutter that you will find in your local hackspace. You need to check that the maximum thickness of different materials is, within the range of what the laser cutter can do. And then, of course, the maximum size. So, if you want to fit a 40 by 40 centimeter square acrylic plate into a laser cutter that can only do 30 centimeters, then that's not going to work. So read up about the basic settings of the machine, or what can be done and what cannot be done with the specific machine that you're working with. Of course, you also need to understand the material itself that you're working with. So one thing to consider is that if you're working with acrylics and you want to engrave the surface, it will turn milky white, so it will turn lighter, right? So if you have transparent acrylics, it will turn milky white. If you have black acrylics, it will turn sort of very light gray type of color. Of course, if you have red acrylics, it will turn light red, that sort of thing. So it will turn lighter. It's the opposite for wood. If you if you burn the surface, it obviously looks a little bit burnt, so it gets a little bit darker, and depending on your specific settings, you can actually create different types of burn marks. So when I worked with these the labels that says drinks on the front here, I actually had to tweak the settings a little bit because I wanted it to look way more, like have more contrast. So I wanted the letters to be as dark as they are now, because the initial settings actually were very sort of light. Yeah, just like you could barely read it, basically. So sometimes you need to tweak the settings a little bit. And when we're working with the plastic mirrors that I showed you before, there's a couple of things that you need to consider. First of all, this time you're not working on the top layer, but you're working on the back layer of the acrylic, because the mirror, the coating is, the reflective coating is actually on the back side of the acrylic. So you need to turn it upside down. If you're working from the back, this also means you need to mirror your design, because if you don't mirror the design, especially if you have a non-symmetrical logo, or if you have letters on, writing on it, text, this will be this will be flipped around. This will be mirrored. So you need to mirror it in order for you to, when you swap it back around the right way around, that it will actually read correctly. Right? So you need to mirror the design. And on top of that, you also need to negate your design. So instead of, because what you do with engraving is you're kind of emphasizing the area that you're engraving. And this is true for acrylics and also wood, even though one turns lighter and the other one turns darker. But when you're working with reflective coatings, what you're doing is you're taking away, you are removing the mirror properties in specific areas, but the areas that will look emphasized are the mirrored parts, right? So what you want to do is you want to remove the inverse. So if we go back to this image here, actually, this is a bad example, because I think here I actually forgot to do it the other way around. So as you can see, the area in this case, actually it doesn't really matter because it's kind of a flame, but really it should have been the other way around. So you really want to be able to engrave this area and leave the other bits out. So depending on your design, you might want to do that or not. So just consider you need to mirror the design in order for letters to be showing up the right way around. And you also want to negate your design. Is that we have a bunch of things that we probably don't want to be processed, and that is all of these basically comments. Like I don't want the bottom of my box to read bottom, and I don't want top right next to the letters of my project, right? I don't really want that. So I don't really want to, but I might want to keep these just for reference, so I know that what's what. But I might not actually want to engrave or laser cut these things. So if you treat every single object, if you simply process every single object, these will also be processed. I actually do this quite often, that I, especially for more complicated projects, that I might put comments into it, why I did something a specific way, or what I need to adjust in order to adjust for something else, or something like that. So all of these are just notes to myself that I don't really want to be laser cut or engraved into my project. So simply loading the file and treating everything that you've got in there might not be the best option. If you have a very simple file, of course you can do that. But I actually prefer sorting the file by color. So and this is, I feel like, is the most intuitive way. So what I usually do is I actually don't use black what I tend to do is I use something like, can we go to RGB maybe? Makes more sense. Let's pick this one. Okay, so let's go blue. So what I usually do is red and blue. Like I usually tend to use, just because I'm used to these generated files, so I usually use red for the lines that are to be laser cut, and I use blue or green or some other color for the areas that are meant to be engraved. Now I'll know that this is red, so this will be cut, right? And this blue area is meant to be engraved and not cut out. And what I usually do as well is I create a tiny little, that's not what I wanted. I want a square box. And I'm actually going to change the colors of it. So let's use, I don't know, yellow. This interface has changed. Let's use green. Let's zoom in as well. So we have green on the outside, and the filling, let's make it, I don't know, pink. So now we have different colors that are different from the red and the blue over here. And what I usually do is I set this to 10 by 10 millimeters. And I usually position it at the very top left corner. So now I not only have a little bit of a reference in terms of size, but also I have a little bit of a test object. So what I usually do when I load my file into the laser cutting software is I tend to process this one first, because I actually want to test the material. So I tend to find a corner or make space at the top left corner, because this is actually a really good reference point, because this will also be the reference point of your actual laser cutter, like the home position of the laser itself. Once you, like, that's something you need to adjust, but somebody will show you how to do that on the laser cutter, but this is basically your point of reference. So if you want to start over where you left off last time, this is actually really good to have this corner here defined on your material, because there might be an offset, like the material itself might be a little bit bigger, and you might decide if the edges aren't clean or something like that, or a little bit dirty or something, I don't know, scratched, you might want to decide to move everything in a little bit. So this might not correspond to the actual beam. So what I usually do is I would open up this file in VisiCut, and then select cut everything that's green and engrave everything that's pink, and ignore everything else, the rest of the project. And what I really want to find out is, for that specific material that I'm using, are the laser cutting settings correct, and does everything work the way I want it? So this is both a reference point and a bit of a material test. Now, if you're repeating the same project with the same kind of material over and over again, of course, you don't need to do this every time. So if I actually already, if there's multiple boxes like we had before, like here I have a whole stack of 4 drink holder boxes that are all pretty much identical. I don't need to have this point of reference every single time. So next time I actually want to process the job, I will open up this file and simply tell VisiCut, please cut everything that is red, and please engrave everything that is blue, and ignore the rest, which means both ignoring this reference point at the top, but also ignoring these comments or labels that we have in the file that we don't actually want processed. So that's why I recommend using color, because it's the most intuitive to deal with. Yeah. And then you also need to understand how the laser cutter, or how actually the software of the laser cutter, interprets the file, the objects in your file. So these are the really important things to look out for. So basically, what I said before, I already spoiled it a little bit. This as a text object will not be, depending on the software, might be processable, but might not be, especially if you're using custom fonts. This will change if you open up on a different computer where the font isn't installed, so you really don't want to be using fonts. You want to always convert fonts into vector paths. But another thing to look out for is that, like I said before, the thickness of a line doesn't matter. So if I look at the definition of this, I can see that there are 4 path nodes defined for this path, and